the interrupt structure of 8085. Right. Now suppose 8085 or processor, not writing, sorry, 8085 is executing a very lengthy program, right? Very lengthy program, and I'm just giving you the example of that program. Suppose here we have a program starting from say 2000H, right? Here we have written MVI A45H, ADI 01H, DAA, right? This way it is increasing, and finally here it is written say like this, JMP 2000H, and here we have halt, right? So suppose for executing this program, right, the starting address of this program is given to microprocessor. So PC will be having 2000H, right? First of all, PC will be outed, MVI A opcode will be fetched, right? Then PC, right, PC will be incremented to 2001, right? Then 45 will be fetched and it will be transferred to... Hello?
Sir, your
Screen is not visible, sir.
Oh, sorry. In fact, I went out earlier. Okay. So now I'll just rewrite once again so that everything will be clear. Right. So I should record also. Start record. Right. MVI A45H move B comma A, right? Add ADI 45H STA to 2600H, right? Then okay, this we were knowing, no? This we have discussed in say 80H. What exactly it is going to do? Hello? Suppose this instruction is executed by processor in 80H. What exactly processor is going to do? Abhik Sen? Abhik Sen. This is 8085. Right. Here we have memory, ROM, RAM, and here we have IO ports. Memory as well as IO ports are connected to 8085, no?
Yes, sir.
So if processor is executing in 80H, what will happen?
Sir,
right, this is port 80H, this is port 81H, this is port 82H. What will happen?
The processor is taking input from port number 80.
80. Suppose here we have a temperature sensor, right? And temperature
Yes, sir.
sensor data is digitized, right? Temperature sensor data is digitized and it is stored over here,
Sir.
right? So in ATH, it means say whatever is the temperature outside, right, is sensed and digitized, then it is kept at say port ATH, right? So if in ATH is executed, temperature data will come into the accumulator, no?
Yes, sir.
Right. Now suppose at
Yes, sir.
port 82H, we have a display unit, right? Suppose here we have corresponding temperature data is 2, 5, right? So now it will do what? Out 82H. So what will happen? In ATH, then out 82H. What will happen?
Sir,
Here
accumulator
it will be 2, 5, no? After,
yes,
right? Now out 82H. So accumulator content will be placed in this over here. And since display is connected to this port, what will happen? Here you are going to see a display like this. And here, say it is marked like degree centigrade. Okay. So let us write the program for displaying continuously the temperature, which is over here in this say chamber. A sensor is there which senses the temperature, right? And corresponding signal conditioning unit. Then we have ADC over here, right? So for inputting ADC data, which is nothing but 2, 5, 2 means 0, 0, 1, 0, 5 means 0, 1, 0, 1. So this will be 25H. And this is corresponding temperature. 25 degrees centigrade is over here. And this is being sensed by the sensor, right? And we have signal conditioning, some electronic circuitry, which is converted to voltage. Then this voltage is digitized, analog voltage is digitized, and this is corresponding digital value 25. So this temperature data will be read by this processor by simply writing this instruction in ATH. Now I will write the program over here. In ATH. So in accumulator, you will have 25, which is nothing but temperature data. Now out 82H. So at port 82, you will have 25, and since display is connected over there, so it will be displayed as 25 degrees centigrade, right? Okay. Now this inputting of temperature data, we have to do say at every 3 minutes, every 5 minutes. So now I will do say call delay of 5 minutes, right? Then again we have to check if temperature has changed here or not. So suppose here temperature is 26 degrees centigrade after 5 minutes. So again inputting of port 80 has to be done. So in ATH has to be repeated, then out 82S, so that here it will be 26 degrees centigrade. So what should be our instruction now? Over here, क्या instruction लिखना चाहिए जी? Hello? बोलिए। हेलो Abhishek Agrawal, what will be the instruction over here? Abhishek Agrawal, it is being recorded, and last time also I saw even after class you were in the meeting, and I rejoined. That time also I found you that you were in the meeting, and I so many times I called you, but you were not responding that time. Abhishek Agrawal, here, अरे भैया, we discussed no in and out instruction, we discussed or not, right? And if you have missed that class, recording is already there.
Yes, sir, it is there, sir.
So in ATH, that time someone said no, that from port ATH, data will come into the accumulator. Someone said, I said in port ATH we have connected ADC, and ADC is actually digitizing the temperature sensor data, right? Then how much is the temperature? This for displaying, we are sending this one to port 82H, and here we have display is connected, so 25 will be displayed over here, right? Now this reading of temperature data and displaying we have to do at every 5 minutes. So in ATH, then out 82S, these two instructions will be used for reading the data, temperature data, then for displaying. Now this call delay 5 minutes will do what? What exactly this call delay 5 minutes will do?
Delay subroutine.
It will be delay subroutine. So processor will execute this one for 5 minutes. 5 minutes is over. So now it will have to do what? Again, it has to read the temperature data. So what will be the next instruction over here? Again, it will be in ATH, out 82H, or not? So after 5 minutes, again temperature will be scanned and it will be displayed. Then, right, call delay 5 minutes in ATH, out 82H. This way it will be repeated, no? Right?
Yes, sir.
So if you have to do it at every 5 minutes, it means these three instructions has to be repeated. Repeated. These three instructions has to be executed sequentially at every 5 minutes, right? So you will write a unconditional jump instruction, right? Jump loop. So loop will be over here. So processor will keep inputting data from port ATH, and it will keep on displaying the inputted data at port at 82H at every 5 minutes. So this will be our program. Following or not?
Yes, sir.
Right. So now here you can write your halt instruction like this. Right. Now if processor is executing all these instructions continuously. So suppose this program we have started from say 2000H or say 8000H. What will be this? JMP. What address I should write over here?
8000.
8000H. Right. So PC will start from here. Right. Then it will come to this. Then it will come to this. Then it will come to this. And here jump 8000H is going to do what? Hello? Suppose this is how many bytes? This is 8000H. So 8001 H. How many byte instruction is this in ATH? It is 2 byte instruction. Hello?
Yes.
It is 2 byte. Out 82H is also 2 byte instruction. So 8002, 8003. Call delay is how many byte instruction? Call delay. How many byte instruction is this? Any idea? 3 byte. Right. So 8004, 8005, 8006. Then jump instruction will be written at 8007, 8008, 8009, and finally halt at 8008. Right. So first program counter will be 8000. It will read the opcode of in. It will fetch the opcode of in. Then program counter will be over here. It will read ATH. Right. Then from ATH, data will be inputted to accumulator. Then program counter will be over here. It will read the opcode of out. Then it will read the opcode port address from 8003H. Then it will out the accumulator content to 82H port address 82H, and it will be displayed over there. Then it will fetch the opcode of call, which is CD. Then this subroutine address. Then it will come to 8007. It will fetch the opcode of jump. It will fetch 00 first. It will fetch ATH. Then program counter will be loaded with 8000H. In fact, WZ will be loaded with 8000H. WZ will be outed, and incremented value of WZ will be loaded to program counter 8000H. So WZ will be outed, in opcode will be fetched, incremented value of WZ will be loaded to program counter, and ATH will be fetched. This way it will be keep on repeating. Right. Now, suppose it is displaying the temperature. Suppose it is displaying the temperature continuously at every 5 minutes. Now, suppose here we have a pressure sensor. Right. And if pressure is increasing heavily in this chamber, then processor is supposed to, right, turn on a motor and open a valve over here so that pressure will be released. Right. Now processor is busy in inputting this temperature and displaying over here. Now if suddenly temperature that pressure increases heavily, then how to stop this process? Inputting temperature and displaying it, this process will be stopped, right? And processor will open this valve. How it will be done? It will be done via interrupting the processor. So that's why we have interrupting features, interrupt pins. RST 5.5. So moment pressure sensor senses and this pressure is very high, it sends 5 volt to RST 5.5. So now processor job is what? Processor job is to inputting the temperature data and outputting it over here. Its main job is this. But suddenly, right, this operation is required, like this valve has to be opened because pressure has increased to very high value. So a pressure sensor will be kept here, and this pressure sensor, as it senses the temperature increases to very high value, it sends 5 volt to this 8085 via this RST 5.5 pin, right? So moment this RST 5.5 pin is plus 5 volt, processor will understand that pressure inside this chamber has increased to very high value. Now it should stop inputting this temperature data and displaying over here. It should stop, and it has to open this. How it will open, that also we will discuss. So one job is this, right? Next, suppose we have a level sensor also, right? Here we have outlet valve, right? Through this liquid is coming out, and here we have inlet valve through which liquid is being filled in this tank. Now, if outlet flow rate is more than inlet flow rate, what will happen? Hello? If in a tank inlet flow rate is less than outlet flow rate, what will happen? After some time, this tank will be empty, right? After some time, this tank will be empty. So you have to open this inlet valve at full throttle, so that, right, rate at which say liquid is entering to this tank will increase and it will be filled, right? Or if say inlet valve is outlet valve is closed and inlet valve is open, what will happen? Finally this tank will overflow. So we can have a level sensor over here which will tell you that tank is about to fill, so stop this filling process, right? So if tank is about to fill, that time this level sensor will send the interrupt to this processor, right, via RST 6.5. So now processor will understand that tank is about to fill. So to avoid the overflow, it will close this valve, inlet valve. Okay. But main job of the processor is what? To input the temperature data and display it over here. But this process can be interrupted via these interrupt pins. So how many interrupt pins are there in 8085? Hello? How many interrupt pins are there? You can see. It's wrong, right? This trap is incoming. It's not outgoing. Right, INTA is outgoing and it is INTA var. Now this is entire block diagram is wrong. Here instruction decoder and machine cycle encoder, this has to be ALU. Anyway, so these many interrupt pins are there. Trap, RST 7.5, 6.5, this also has to be incoming. RST 5.5 and INTR. 1, 2, 3, 4, 5 interrupt pins are there and 1 interrupt acknowledge is there. So in 8085, we have 5 hardware interrupt pins. First pin is trap. Second one RST 7.5. Fourth one, RST 6.5. RST 5.5. And fifth one is INTR. Right? And one interrupt acknowledge pin is also there, INTA bar. Memory plus IO device. Hello? So we have 5 hardware pins, hardware interrupt pins. Out of these 5 hardware interrupts, trap is non-maskable. Right? RST 7.5, 6.5, 5.5 and INTR are maskable interrupts. INTA bar is actually interrupt acknowledgement. Interrupt acknowledge. Right. Out of these 5 hardware interrupt, trap RST 5.5, RST 6.5, RST 7.5 are vectored interrupt. While INTR is non-vectored. Right, while INTR is non-vectored, I will tell you the vectored address of these no, it is not mentioned over here. So vectored address of these, this one is 0024H. I will start with this 0000. This is RST 0. 0008. This is RST 1. 0010. RST 2. 0018. RST 3. 0020. RST 4. 0028. It is RST 5. 0030. RST 6. 0038. RST 7. Right. Now here vectored address 0024. 0024H is vectored address for trap. 002C is vectored address for RST 5.5. Then 0034 is vectored address for RST 6.5 and 0036 C is vectored address for RST 7.5, all hex. Now I'll go new slide. Hello, Mahavadi. Are you listening?
Yes, sir.
Okay. Now, suppose you are preparing for some exam, right? You are preparing for some, say, online test, right? For that, suppose one chapter is given or one module is given to you that you just go through this, right? At the evening, you will have the test. So what you will do? First of all, around say 9 o'clock, at 9 a.m., right? After getting the breakfast, right? You will start preparing, no? So in module 1, suppose we have say 7 topics we have to study. 7 topics you have to study. And you have say around how much time? Say around 12 hours to go through that. So you will make a, you will just open the all first topic, right? First topic you will start reading, right? In a book, using a book, you will start reading the first topic, right? Then you will go for second topic, then you will go for third topic, then you will go for fourth topic, and finally after going through all 7 topics, right, you will be ready for giving the exam. Is it okay? This way you will prepare, no? Hello?
Yes, sir.
This way, right? Suppose more, this topic 1 is prerequisite to topic 2, right? Topic 3 is is having prerequisite of topic 2, like, so you cannot go directly, you cannot go to topic 7. So first of all you have to study topic 1, then topic 2, topic 3, like this. And this all topics are very, very lengthy one, right? So around 9 a.m. you started the preparation, right? You started with topic 1, then you went for topic 2, right? So this is your main job, right? Going through all 7 topics in serial order. Now in between, right, you may feel to have some coffee, right? You may need to go washroom. You may need to right, you may need to go washroom. You may go for having some snacks in between, right? You may need to go for having bath around say 12 o'clock, right? And then around 12:30 you may be taking your lunch, right? Like that, means this type of, right, interrupt may come in between your these this topic preparation. Topic 1 you are studying, then topic 2, topic 3, topic 4, topic 5, like this. So to have a coffee, where you will go? You will go to kitchen, no? Hello, Mahavadi.
Yes, sir.
Right? Of course, for you want to fresh, then you need to go to your washroom. For snacks, right? Or having some sweets, right? you may go to kitchen, or you may go to place where your, okay, not snacks, you want some cold drinks, right? And your fridge may not be in the kitchen. So fridge location may be in the dining space, right? So for having cold drinks, you may need to go to dining hall, right? For lunch also, you have to go to dining space, to dining table. Then again, you may need to go to, say, washroom, right? And this is where exactly you are going to study all these things? At your, inside your room, where the study table is there. Is it not? Right. So you can see, for having coffee, you have to go to kitchen, right? For having cold drinks, you have to go to dining hall where fridge is there, right? So how you are going to do this? Now 7 topics you are supposed to prepare. So you are studying topic 1. Now suppose you may feel go to washroom. So you will go to washroom. Then you will come back. You will study topic 1. Topic 1 is over. So you will go for now topic 2. You may feel to have coffee. So you will go to kitchen. You will prepare coffee, right? Then you will come back, right? You will take coffee. Then you will start. You will proceed with your topic, right? Then after some time, you may feel to have cold drinks. So you will go to dining hall. You will open the fridge. Then you will come back, right? You will have your cold drink. Then you will proceed with your topic 3, right? So this way, so many interrupts will be coming in your main program, right? And their interrupt service routine. For coffee, you have to go to kitchen. For, right, getting fresh, you have to go to washroom, right? If you want cold drinks, then you have to go to dining hall. Hello? हेलो, आवाज नहीं आ रहा है? Right? And these interrupts are vectored. So if a RST 7.5 interrupt comes, processor will branch where? 003C. Hello?
Yes, sir.
From main program, processor is executing its main program from 2000H. If RST 7.5 comes, processor will stop executing main program. It will branch to vectored location of RST 7.5. Okay. Now, if RST 5.5 comes, if this interrupt is coming, processor is executing main program, what will happen? Processor will branch to vectored location of RST 5.5, which is 002CH, and it will start executing the subroutine at that point. Like if you are going to kitchen for having coffee, right? You have to do some work in order to prepare coffee, no? You have to turn on gas, you have to put kettle and, right, at the top of your burner. Then you have to, right, take coffee, water, milk, right? Then you will wait for, right, sometimes so that water boils, right, and coffee is prepared. Then you take it, right? Right. After having coffee, you will start reading your different topics over here. The same way here, if a RST 7.5 is coming, processor will stop executing its main program. It will branch to vectored location of RST 7.5, right? And here, whatever program is there, it will be executed by the processor and it will come back to main program. So what type of program will be over here, right? Here for turning on valve, for turning on, turning off the valve, for closing the valve, for avoid the overflow, you have to turn off, no? Now this turning on and turning off the valve, very easily it can be done simply by outing 0 at SOD pin. You can turn off a valve or you can turn on a valve by simply outing 1 at SOD pin. Right, of course, some electrical circuitry will be there along with some current current amplifier, right? Some circuitry, electronic circuitry will be there which will turn on the switches or turn on the motors, which will rotate the valve and it will close the valve, right? So how many vectored interrupts are there? 4, right? And so in these locations, corresponding subroutines will be there, right? Corresponding subroutines will be there. Next, out of these, suppose these two interrupts are coming together, RST 6.5, where? Here. Suppose this is RST 6.5 and this is RST 7.5. Now this RST 6.5 is generated whenever water is overflowing, right? And RST 7.5 is being generated whenever pressure inside this chamber becomes very high. So if both sensors are sending the interrupt signal to both at both pin at their respective pin at a time, then where exactly processor is going to branch? Which service routine it will do? 6.5 or 7.5? Hello? Mahavadi?
Yes, sir.
So here you can see if temperature is, if pressure is very, very high, then this chamber may blast, right? And so much damage can occur. So much damage will be there if chamber blasts, right? But if water is overflowing, there won't be any problem. Hardly 5 liter, 10 liter water will overflow. There won't be any problem. It is not costly. So priority of RST 6.5 we have to keep lower. If both are coming at a time, first of all, processor will do this job, RST 7.5 job. Why? Because here if pressure is very, very high, chamber may blast, accident may occur, right? So we have to stop this first. Then we can go for switching off or closing the inlet valve of this tank so that overflow will stop, right? So we have priority also. Priority of interrupts are there. So, right, INTR has got least priority and trap has got highest priority, and it is non-maskable also, highest priority and non-maskable. While INTR has got least priority, RST 5.5 is having higher priority than INTR, and RST 6.5 is having higher priority than 5.5 and INTR. RST 7.5 is having higher priority than RST 6.5, 5.5 and INTR. So among the maskable interrupts, RST 7.5 is having the highest priority. Hello? Hello?
Yes, sir.
So what are the things we have discussed? We have 5 hardware pins which can be used to interrupt the processor. Processor will stop executing its main program and it will branch to subroutine of the corresponding interrupt. Right? If trap interrupt is coming, where exactly processor is going to branch? It will branch to 0024. Right? If 5.5 is coming, then it is 002C, 6.5 0034, 7.5 003C. These are the different vector location where corresponding subroutines will be there. Subroutines means interrupt subroutines. For what purpose? Device is interrupting the processor. That program will be stored in that vector location. So that interrupt subroutine will be executed and interrupting device will be served. Right? Okay. So this is trap, is non-maskable. This also, right? Trap is non-maskable. Processor cannot ignore this. If trap interrupt is coming, it has to branch to 0024. And this is used by this system only in case of power failure or emergency case. This trap interrupt is generated and automatically whatever data is required to be saved and all, it is done during that, right? While this RST 5.5, 6.5, 7.5 and INTR are maskable. Maskable. Maskable means suppose at every 5 minutes, right, temperature has to be inputted and it has to be displayed, right? And this has to be done via RST 7.5 is used, 6.5, so RST 5.5. Now main program is something else. It's not inputting this. So if temperature data has to be inputted and it has to be displayed, device generates the RST 5.5, right? So this will be the subroutine of RST 5.5, right? Of course, here this halt won't be there. Here it will be RET, return instruction will be there, right? And this should not be there, right? So if inputting of temperature data has to be done, how it will do? It will in ATH, then it is displays, it displays the temperature data, then it is returning to main program. RET will be over here. Right? Now suppose for RST 7.5, right? It has to open the valve, and for opening the valve, it has to send, say, 5 volt to SOD pin. How it will do? It will do MVIA C0H SIM. So SOD pin will be how much? SOD pin will be 5 volt. No? Hello? And this 5 volt can be used to turn on this transistor, right? And this transistor can be used to energize a 12-volt relay. Right, 12-volt relay. And this 12-volt relay can be connected to a motor. Right, and motor will rotate, and right, this outlet valve will open. So this will be the subroutine for what? RST 7.5. Right. Now suppose for closing the valve of the tank, right, RST 6.5 is there. Right. In this case, you have to move, say, MVIA FFH out 81H. So what will happen? In 81H, this port FF will be outed. Right. FF will be outed, and this FF can be used to, FF means how many ones are there? 1, 1, 1, 1, 1, 1, so many. So you can, simple one can be used to turn on one motor. This can be used for turning another motor. Right. So even though either FF or even 0, 1, if you do, then all will be 0, and one bit will be 1, which will be used for turning off the valve. Right. So this way you will have the subroutine for each and every interrupt. Right. Now, one thing you need to understand, this is what 000H, 0008H, 0010H, 0018H, 0020H, 0024H, 0028H, 002CH. And after how many location RST6 address is there? 2C, 2D, 2E, 2F, 30. So only 4 locations are there, no? Right. Hello, Mahavadi.
Yes, sir. Listening, sir.
Only 4 locations are there, and in these 4 locations, can you write a subroutine? Only 4 byte subroutine is very difficult, no? Even this one takes how many? 1, 2, 3, 4, 5. Here, this one has taken 4, then RET, 5 bytes. Here, 1, 2, 3, 4. 4 bytes are there. Right? But our subroutine is not going to be this much simple. Right? Our subroutine will be little bit lengthy one. So definitely these subroutines are not going to fit within these 4 locations. Right? And very, very important, these locations are nothing but what? Roam location. Hello? Hello?
Yes, sir.
These locations are roam location. So you can't write your subroutine. Right? This subroutine you have to write in RAM. Right? This subroutine you have to write in RAM. Okay. So what will be the written in these 4 locations? So let us check. I will go to that. This is visible. Hello.
Yes, sir.
Now I am going reset examine memory 0034. Next. अरे ये क्यों हुआ जी? Here room area we cannot see, no? Okay. We cannot see over here, but why can't we see? Examine memory I'm doing, reset examine memory. Next, if I do error, now we cannot see the room area over here. This is simulator, but in practical kits you can see, right? Reset examine memory 003 C. Next error. No. So we cannot explain this, right? Using the simulator, actual we cannot see the room location. In fact, in those room location, whatever vector locations are there, okay. So let us have a new slide. So it is 002C. It is RST 5.5. In this 2D, 2E, 2F, right? We have only 4 locations. Similarly, RST 6.5, 0034, 0035, 0036, 0037. 4 locations. RST 5.5, 7.5. It starts with hello. RST 7.5, 003C, not H. Everywhere it will be H only. Right. So definitely in these 4 locations, you cannot write your subroutine. Only 4 bytes is 4 byte space is there, and with that these are room, right? These are room locations, so you cannot write anything over here. 3D 003EH 003FH. You cannot write anything over here. So in fact, kit manufacturer is going to provide you, right? Is going to provide you what? With these instructions C3 0090, and this is not needed. C3 00A0, and this is not needed. C3 00B0, and this won't be needed. What is this? This is JMP, right? JMP. This is opcode for JMP. This is also opcode for JMP. This is also opcode for JMP, jump instruction, right? So if RST 5.5 interrupt comes, program counter will be this. Program counter will be 002C. Now this instruction will be fetched. C3 will be fetched and it will be executed. C3 stands for jump. So from here, where exactly program counter will jump? It will jump to 0090. So 9000, here program counter will come. And here you will have ISR of, you can write ISR of RST 5.5. Why? Because this 9000H is, hello? 9000H is RAM location. Here you can write your own ISR. Hello? हाँ नहीं नहीं ये चौधरी सर का कहना हमको अभी थोड़ी सवेरे बात हुई सर, शाम को नहीं हो पाई थी हमारी। इनका कहना है कि ये जो राडार जो है आप ही पढ़ाइएगा, और ये जो है ये जैसे है कि पीजी लेक्चर उनको देना है करके कह रहे हैं, उनका यही कहना। हाँ ठीक है सर, ठीक है सर। तो ठीक है सर। Hello. Hello.
Yes, sir.
Mahavadi. Right. So, in fact, in these 4 locations, you cannot write your ISR. Right. So, kit manufacturer is going to provide you the RAM location. Right. So, it is standard. Right. In fact, in 8085 itself, it is decided. Intel people have decided that these vector locations for RST 5.5 will be 0026, right? Kit manufacturer, right, which will add 8085 RAM, ROM. So kit manufacturer will be knowing what is the ROM area, right? And of course, ROM will start from 0000H and it will end somewhere. So kit manufacturer will be knowing what will be your RAM area. So they are going to provide you, of course, in 002C, it will be C3 only. And these 2 locations, 00 and 90, will be provided by the kit manufacturer, which is nothing but RAM location, where a user can write the corresponding ISR. Okay. Hello. Mahavadi.
Yes, sir. Yes, sir.
Now, suppose your ISR is already at say 8500. Already you have written an ISR of 5.5. ISR already you have written, right? Interrupt subroutine already you have written. So what will happen? Processor will branch to 002C first. From here, kit manufacturer is provided 0090. So processor will come over here. Now you have written your ISR already in 8500 onwards. So what you are supposed to write in this area? Hello? At 9000H, what you are supposed to write? Your actual ISR is at 8500. RST 5.5, ISR is at 8500. So if interrupt comes over here, then it branches to this. If interrupt comes over here, then it branches to 9000H, right? And your subroutine is not here. Your subroutine is actually at 8500H. So what you are supposed to write over here? Mahavadi.
Sir, first we have to write the address of the RST 5.5 now, sir. 002C.
Now 002C is already written, no? Right. Processor will come to 002C. From here it will go to 900. And actually your subroutine has to be over here.
Yes,
But
sir.
already you have written your subroutine at this point, 8500. So what you are supposed to write over here?
Sir, we will jump to 8500 location.
Yes. So this will be C3 00. This will be 85. Okay. And from here it will branch to ISR. Your actual ISR over here. Then from here it will return to main program. Right. Now, these high hardware interrupts are having different sensitivity. You can see RST 7.5 over here is actually S triggered. S triggered only. You can see over here, it is S triggered. While this RST 5.5 and 6.5 are actually level triggered. And INTR is also level triggered. While this trap is edge followed by level. Right? What exactly this means? It means if at RST 7.5 pin, this type of signal is coming, a sudden change from say 0 to 5 volt is there, and even though it is not continuing after this, processor will recognize this. RST 7.5 interrupt has occurred. But in case of RST 6.5, if suppose signal is of like this, right, then it is not going to be recognized by the processor. Signal has to be right 0 to 5 volt, and it has to remain there for longer duration. So it is called, this is called level trigger. Similarly, 5.5 is also level trigger. Right? RST 7.5 is S trigger. While this trap is edge followed by level. INTR is also level trigger. Hello. It means in say, where is that? I'll put a new slide over here. New slide. (8085), and we have interrupting device. Interrupting device 1 is interrupting processor via RST 7.5. So if this interrupting device generates a signal like this, a spike is generated, RST 7.5 will be recognized by the processor. Second interrupting device, IDEV2, is interrupting processor via say RST 5.5. So if this device is generating this type of signal, 8085 is not going to recognize this device 2, right? This signal has to be 5 volt for long duration, right? Then only it will understand. Okay, device 2, you are interrupting me, I understood, and it will generate INTA, right? Okay, then third device, IDEV3, is interrupting this one, say RST 6.5. So this also generates this type of level signal of 5 volt, then only it is recognized. So RST, it is edge triggered. These two are level triggered, while trap. Similarly, INTR is also level, but trap is edge signal, edge triggered, followed by level, right? In this case, in case of RST 6.5 and 5.5, suppose voltage is increasing slowly, and after that it becomes 5 volt and it remain over there, then it will be recognized. In this case, also if voltage is increasing slowly, then it remain over there for long duration, then 6.5 will be recognized. But in case of trap, right, signal has to rise suddenly from 0 to 5 volt like an edge of this RST 7.5, and then it should remain over there. In case of RST 7.5, even though after changing from 0 to 5 volt, if signal is removed, then also that 8085 is going to record the interrupt. But in this case, even though if it's changing from say 0 to 5 volt, and if it is not continued, then trap won't be recognized. So there has to be sudden change followed by level. So sudden rise from 0 to 5 volt, and it remains over there for long duration, then only trap is recognized or trap will be serviced. So trap is non-maskable, it is used in emergency cases like power failure, right, power failure and all. So this has to be done very, very carefully, right, so that processor goes to trap subroutine and it manages the power failure and other factors, right? So why trap is edge followed by level? Hello? Suppose at this pin, due to noise, suppose a spike comes. What will happen? Trap will be recognized. Unnecessarily, it will shut down and restart the system. Right? Unnecessarily. Monitor program and everything will run, and it will reset your system, or right, it will save the program unnecessarily. So that is why, to avoid the false triggering of this trap, right, due to noise and all, edge followed by level is done. Right. So why all these triggering sensitivity are different? Of course, for trap it is clear, edge followed by level has to be there in order to avoid the false triggering of trap interrupt. Then why not for RST 7.5 also it is like that, edge followed by level, and here also edge followed by level, here also edge followed by level, because these devices may not be able to generate, these interrupting devices in some cases may not be able to generate edge followed by level. Right, this device is generating 5 volt, but it's generating 5 volt, but initially it increases very slowly, then it becomes 5 volt. So edge generation of edge is not possible over here. Now I am just giving you the another example. Right. For example, suppose at check post, right, police check post, you have to count number of heavy trucks. Right. Normally at check post, we used to have barricade as well as what? Barricade as well as speed breaker. You will find it will be there. So if a very long truck, right, is crossing this say speed breaker as well as barricade, right, it will take so much time, around say 4 to 5 seconds. Right. Now we can have a sensor. Right. We can have a sensor, light source. Right. Light source which will inject the light. And here you will have an LDR. Right. So if light is falling on it, what will happen? Suppose this is LDR. This is LDR, and here we have light source. Right. And if light falls on it, its resistance becomes very less, say 1 ohm or say 10 ohm. And this is say 1 mega ohm. And this is 10 volt. So how much will be voltage across these 2 points? This is say 10 mega ohm, and this is 10 ohm only. So if light is falling on LDR, light dependent resistor, right, this 10 ohm is very less resistance. So how much will be voltage over here? Hello?
Sir, negligible voltage.
0 volt. Right. Now suppose a truck is crossing. Suppose a truck is crossing and it is obstructing the light, then light is not going to fall over here. So its resistance is very high. Suppose it becomes 10 mega ohm. What will happen? How much will the voltage? This is 10
Five.
mega ohm. Huh? This will be 5 watt. Huh? So you will get this type of pulse of 5 volt. Hello? Right. So whenever a truck crosses, right, this sensor will give you 5 volt. This can be used to interrupt the processor via RST 5.5. And processor will branch to its vector location 0024. Right. And here you will find C3 0090. No? From here it will jump to 9000 H. So here either you can write the subroutine for counting number of trucks, INR B. It will increment the count. Or if you have to count in BCD, how to write the ISR? Move A comma B ADI 01H DAA, right? Move B comma A return. So in B register, number of trucks will be counted 01, 02, 03, 04, 05, 06, 07, 08, 09, 10, 11, 12, like it will go up to 99. Hello? Whenever truck is crossing, what will happen? Processor will branch to ISR, it will increment the count, and then it will return back to main program. Right. Now suppose here, in this case, right, here we have a Formula 1 racing track, right? And this one is the finish line. And if a racing, right, if a racing car is crossing the finish line, what type of pulse you are going to have over here? Huh? Like this. Is it not? Hello?
Yes, sir.
Now you have to count how many cars has finished the race. Then how you will do? Can you go for RST 6.5? Hello? Can you go for RST 6.5?
RST 7.5.
RST 7.5 you will select, no? RST 7.5 you will select. Right. So suppose RST 7.5 you are selecting for counting racing cars. This is for trucks. This is for say this is for say I'll give you another example. Now suppose here we have a level sensor. level sensor. And this here we have float. As this liquid level increases, this float keep on moving up, right? And this is mechanically linked with this potentiometer, right? And this is say around 6 volt, right? So how much will the voltage right now between these 2 points? Around say 2.5 volt. Now as this liquid level increases, right, float will be over here, and this mechanical link will move up to this, and that time this voltage becomes 5 volt, right? So how voltage is going to increase? 5 volt, and then it will remain over there, right? After this, overflow will start, and this float is not going to move up further, so it will remain over there. So this device 3 can be used for, say, interrupting the processor whenever overflow is there, right? Then next we have a pressure sensor. If pressure becomes very high, then 5 volt is generated like this. Then how to interrupt the processor for opening this valve? Already we have engaged, no? This is for counting trucks. This is for counting cars. This is for checking the overflow. This is right. Now we have to, right, if pressure exceeds, then we have to interrupt the processor for opening the valve. Trap is you cannot use. So how to interrupt the processor now? Already all these 3 vectored interrupts are engaged. Hello?
Yes, sir.
So for that, what we have? We have this. Trap RST 5.5, RST 6.5, RST 7.5. Then we have INTR. Right? INTR. Then we have INTA bar over here. So this one is, all these are engaged now. All these are engaged, no? So only this one left. So now, if you want to increase the number of interrupting device, you can interrupt the processor via INTR pin. Right? And INTR is non-vectored. INTR is non-vectored. So where you are going to write the ISR? There will be interrupt service routine. Hello? Where will be ISR of this INTR? Okay. So now, actually this INTR signal will be sent by an interrupt controller. In fact, this interrupt controller chip is used for expanding the interrupt facility. Right? Now here, this interrupt controller, right, can add 8 interrupting device, INT0 to INT7. 8 interrupting device can be connected to this interrupt controller. Right? Why? Because this RSS 6.5, 5.5, 7.5 are engaged. So we have to further, we need to interrupt the processor. Then we will go for an interrupt controller, which will interrupt the processor 8085 via INTR. Okay. Now, out of these 8 interrupting device, which one is interrupting processor and where is the ISR will be given by this interrupt controller. ISR address, sorry, Control Z. Interrupt subroutine address, right, AD0, AD7. Interrupt subroutine address will be provided by this interrupt controller. So whenever INTR signal comes, right, when INTR signal comes to 8085, it sends interrupt acknowledge, INTA bar, to interrupting device. 8259 is the interrupt controller. Now this 8259 is going to provide right. So INTA will be this type of signal, low. First it will send this, then lower order address will come to the processor, right, and it will be stored in Z, right. Then again processor is going to generate INTA signal. Then this 8259 is going to provide the higher order address of the subroutine, and this will be stored in Z, right. Now this WZ will be outed via A8 to A15 and AD0, AD7. ALE will be made high and incremented value of WZ will be loaded to program counter, right, so that ISR execution will continue. Okay, ISR address will be provided by 8259. How? Moment it sends the INTR signal to 8085, it responds with INTA bar. It's like this. INTA bar means 8085 makes INTA signal low. So 8259 sends lower order address of the ISR and 8085 keeps that lower order address in Z register. Right. Then 8085 again sends the INTA low signal. Right. Then 8259 sends higher order address byte of the ISR and 8085 keeps that one in W register. Right. So ISR address is this. From here, now execution should start. So W will be outed over here and Z will be outed via AD0, AD7. Right. So at WZ location, right, ISR will be executed and WZ plus 1 will be loaded to program counter. Right. Then program counter will be outed, which will point to next location. This way it will continue. Finally, it will encounter the return instruction and it will return to main program. Okay. So what is the use of INTA signal? Now it is clear. Hello.
Yes, sir.
This is interrupt acknowledge. right? This interrupt acknowledge is made low whenever any interrupt comes to the processor, right? And whenever any interrupt comes to the processor, and if it is not masked, then processor is supposed to serve that interrupt. It has to branch to that ISR. Now, before branching to ISR, processor disables all the interrupt so that it can execute the ISR without any interruption. Okay. So you can see over here, INTA signal. Where is INTA signal? It's not shown over here. This image is also not clear. So anyway, in next class, we will discuss in detail programming related to interrupt. Right, programming using 8085 interrupt facility.
Sir, can we leave, sir?